it comes to bioenergy and renewable energy, you just want to minimise waste, and you want to find ways of using every single scrap of biology and every single scrap of industrial waste to generate more energy. So the idea here is that you could engineer a bacterium to produce hydrogen, produce more hydrogen. Okay, so then you could take food waste and you could sprinkle in your engineered E. coli and it would produce hydrogen gas. Then you want to produce electricity from that. Then now you've got a problem, because if you make a fuel cell, you make it out of precious metal, and that costs a lot of money. So what we discovered in this paper was that if you take a different E. coli strain that's been engineered a different way, you could mix it with crushed up catalytic converters, which contain palladium oxide that's normally thrown away, and you could pump some of that biohydrogen that you produce from the food waste into this, and those bacteria will take that hydrogen gas and use it as an energy source to reduce their palladium oxide back to palladium metal. And those palladium metal nanoparticles form on the surface of this bacterium. Then it dies and it falls to the bottom. But then you can harvest that, so then you've got nanoparticles of palladium, and you can paint that onto a plastic sheet and make a bioelectrode from that. So then you can take your vat of food waste, sprinkle in your bacteria, produce hydrogen, and you could make electricity from a fuel cell that's been made by bacteria using bio-nanoparticles that come from your crushed up catalytic converters. So then you start to get this whole cyclical process, that everything's renewable, everything's sort of biologically based, and we're using waste catalytic converters to make a fuel cell, we use waste food products to make the hydrogen. It's done by engineered bacteria. So you could really save a lot of money and generate electricity that way. And actually the biopalladium nanoparticles that we generate are much more efficient at producing electricity in a fuel cell than chemically produced particles of precious metal are.